Hi everyone, let's discuss one more theorem that every open ball is an open set. So what they have given to you? One open ball is given to you and you have to prove that it is an open set. So what is open ball? Open ball is nothing but collection of all the point of your Rn such that its distance from that point x to p is always less than r. So here this is your Rn space, okay, and here there is a ball with a point center p is the center and there is a ball around of radius r, okay, and we have to prove that this ball is your open set. The open ball is nothing but it is a set and you have to prove that it is a open set. So to prove any set is an open set, what we have, if you want to suppose they have given you one set A, and if you want to prove that it is an open set, so what we have to do, we have to show that all the points of this set are an interior point. To prove all the points of this set are interior point, what we have to do, we have to take one arbitrary element p naught from A and we have to show that there is an open ball around that point p naught and that open ball is totally contained in the A. Then only we see that A is a open set. So here also we have to prove that this is an open set. It means that we have to show that all the point of this open ball, all the points, these all x1 x2, these all are the interior point p naught. We have to prove that all these are the interior point. So to prove this ball is the interior point, what we have to do, we have to take one arbitrary point and we have to take one arbitrary point p naught and we have to show that there is a ball around that point p naught and we have to show that that ball is totally contained in this open ball. Then we say that this is a open set. So let's see what we have to do. We have to take one point. We have to show that this open ball is an open set. For that we have to take one arbitrary element p naught from this open ball, okay. So if this p naught is belong to this set, it means that the distance from your p to p naught, it will be less than r, because this open ball contain those point of Rn whose distance from that point x to p is less than r. So here I have taken on p naught. It means that distance from your p naught to p is less than r. Now r is positive. Distance between any two point is also positive. Now take this distance between p naught and p to this side. It will become r minus d of p naught comma p. So this is greater than 0. Distance between p naught and p is also greater than 0. It means the difference of two positive integer is also greater than 0. So let it be as your r1, okay. Now take r1 as a r minus d of distance between p naught comma p. Now we got a r1, okay, that is a positive quantity and we have taken on point p naught from this open ball, okay. Now with point p naught and with r1 radius, can I draw one open ball? With p naught and with the radius r1, I can draw the one open ball, okay. That open ball will be p naught comma r1, okay. Now to prove this is an open set, what we have to show, we have to show that this open ball is totally contained in this open ball. Then only we can say that this is an open set, okay. So here to prove this is a b of p comma r is an open set, we have to show that the open ball around that point p naught is a totally contained in that open ball. Then only we see that this is an open set. To prove any two set are subset of each other, what we have to do, we have to take one point from this set. If you want to prove that the set A is a subset of set B, what we have to do, by set theory we have to take one element from a set A and we have to show that the same element is also in the B, okay. Now take one point from this open ball. We have to take one point from this open ball, let y is the element from your open ball b of p naught comma r. If you take the point y from this open ball, it means that distance between the y and p naught is less than r1 because of the definition of open ball, okay. So here let it be as equation 1 and we know that. Now consider, suppose this is your point p and this is your point y and this is your point p naught, okay. Now by triangle inequality, what we can see, that distance between the y and p is always less than the sum of distance between the p naught and p and the sum of distance between the y and y naught or not, for p naught or not. The distance of these this is always less than sum of distance between these two. So here distance of y comma p is always less than or equal to distance between y comma p naught plus distance between p naught comma y. And from equation 1, what we know that distance of your p naught comma y is less than r1. So distance from your y comma p naught or distance from p naught comma y1 is always less than r1. Okay, from equation 1 we can replace this value by less than 1. So less than r1. So this will become less than r1 plus distance between p naught comma p will be as it is. Now substitute the value of r1. So what is the value of your r1? That is r minus distance between p naught comma p. Substitute that value. So it will become r minus distance between p naught comma p plus distance between p naught comma p. So this is negative and this is positive. They will get cancelled and you will get that distance between y comma p is less than r. Okay, what it means? Distance between y comma p is less than r. It means that y belongs to the open ball p of p comma r. So because this open ball contain whose distance is going to be less, x may be anything, x1, x2, y. The distance between the xl comma p is less than r. So this is nothing but x belongs to this open ball. So here if the distance from your y comma p is less than r, it means that y belongs to this open ball b of p comma r. We have taken the y from this open ball b of p naught comma r and we have shown that the same y belongs to this open ball. It means that the open ball b of p naught comma r1, it is a subset of b of p comma r. So what it means that p naught is the interior point of your b of p comma r and this is a open set.